Okay, Algebra 1 fans, our topic for today, this is Notes 6-5, Solve Systems of Equations Word Problems. So, our goal for today, after this lesson, students should be able to set up a system of equations for a word problem, solve systems of equations in real-life applications. So before we start, let me give you your joke of the day. I thought about going on an all-almond diet, but that's just nuts. Almond nuts. All right, so as a warm-up here, let's take a look at this example. Alex buys 2 Big Macs and 3 large fries for $13.15. Jason buys 1 Big Mac and 2 large fries for $7.57. How much is the cost for 1 Big Mac? How much is the cost for 1 large fries? Well, you might be able to think your way through this problem. You might be able to try to plug some numbers in, see what makes sense, but it would be nice if we could take these words and make them into some kind of equation or system of equations. Now the thing is, we actually have 2 variables. We have 2 missing pieces of information. We have the Big Mac, but we also have the fries, the cost of each. So the first thing I'm going to do is called define my variable. Okay, we'll talk about this in a moment. I'm going to say I'm going to use the letter B for Big Macs. Now the B is not going to be the number of Big Macs. They tell me that. They tell me how much Alex and Jason buy. What we don't know is the cost. If you want to use capital letters, that's also fine. B is for Big Macs, and let's say let F equal the cost of fries, of the large fries. Okay, so what we want to do is try to make an equation from this. So let's make one equation for Alex. He buys 2 Big Macs, 3 large fries, and he spends $13.15. 2 Big Macs, the cost. So each Big Mac, we don't know how much it costs, but we're going to buy 2 of them. So let's say that these were $3. The amount he would spend would be 2 times 3. If he buys 3 large fries, the cost of that would be 3 times whatever the price of a large fry is. Now we're going to add the 2 amounts of money to get the total that he spends, which is $13.15. 2 Big Macs plus 3 fries equals $13.15. Now Jason, he buys 1 Big Mac and 2 large fries for $7.57. 1 Big Mac, then he spends money on 2 large fries, 2F equals 7.57. So what we have here is a system of equations. So I'll say equation 1, equation 2. Now, I like to use elimination. So if I wanted to eliminate, I'm looking at the b's. I see 2b. If I could make this a negative 2b, I'd be in business. I'd be able to eliminate. So to make this negative 2b, I'm going to multiply the left side of the equation by negative 2 and the right side of the equation by the same thing, negative 2. Okay, so I'm going to copy the first equation. We didn't change that. So E equals 13.15. This is now negative 2b. That looks nice. This is minus 4f. I have to multiply by negative 2 equals, and this would be 7.57 times negative 2. Let me take a calculator real quick. 7.57 times negative 2 is negative 15.14. Negative 15.14. Okay, now that the 2 equations, we have opposite coefficients, our step here is now to add the equations to eliminate, in this case, the b's. That would be negative 1f equals, that would be negative $1.99. Now we're almost done here. We want positive 1f, so we'll divide by negative 1. F equals 1.99. Okay, so How much is the cost of one large fries? Large fries is $1.99. $1.99 for large fries. But we're not done, because we also want to find the cost of one Big Mac. Well, to do that, we need to find the value of B. Let's go back to the second equation here, which was 1B plus 2F equals 757. But since we found the cost of the fries is $1.99, we'll substitute that. So we get B plus 398 equals 757. To solve that equation, we will subtract 398. B equals, let's see, that would be 9. 17 minus 8, 14 minus 9 is 5. 6 minus 3 is 3. And what we get is 359. Now that's B, but what does that stand for? 359 is the cost of a Big Mac. So those are the two solutions right there. And it's important, when I write my answer at the end, I also want to write what the numbers represent. Okay? This is the large fries cost, this is the Big Mac cost. And that's why I always start my equation by defining variables. I write down what the variables mean so that when I get to the end, then I can remember what they are. Okay, so here's the strategy. Number one, read the problem. We want to make sure we understand what it is that's going on. Step two is interpret the problem. What are we trying to find? In this case, it was the cost of a Big Mac, cost of a large fries. Okay, so you need to read up until the very end, because usually the last sentence tells you what to do. Define the variables. Defining the variables was this part right here. Again, what are we trying to find? Okay, it's almost like you're reminding yourself as you go through these problems what it is you're actually looking for. Then you write the system, you set it up, you solve it, and then you check. Okay, and in terms of checking, in a lot of ways this might be easier. It should make sense. So we had Alex bought 2 Big Macs, and then he bought 3 large fries. Whoop, the Big Mac, I almost made a mistake, 3.59. And the large fries was $1.99. Did he spend $13.15? Check. And then for Jason, he bought 1 Big Mac. He bought 2 large fries, which each cost $1.99. He spent $7.57. Check. So we know that we're right. Okay, so I'm going to give you a couple types of problems that you'll deal with. And the first example here is a money problem. A bank teller has a total of 124 bills. Okay, that's pieces of money. 5s and 10s. We're using, this is American money. $5 bills, $10 bills. The total value of the money is $840. How many of each kind does he have? One thing you need to understand is that when they give you numbers, you're probably going to use them. And remember, since we're doing systems of equations, we're going to need to have 2 equations. So we'll need to have 2 values for this. So what's the question? Let's interpret the problem. How many of each kind of bill does he have? Now we have 5s and we have 10s. So on the side, I'm going to define my variable. I'm going to say let's do F for the number of 5s. And I'm going to use T for the number of 10s. But notice that I'm going to write my T with a curve because my T's look like plus signs. Now, if that's confusing to you, pick a different variable. Pick N, pick X, pick anything you want. You can even use capital letters, but I need to be very clear here. All right, so interpret the problem, okay. Define the variables, okay. Set up a system of equations. So now we need to write the equations. Well, they give us 2 numbers. 124 that represents the number of bills. Now look at how we defined our variables. F is the number of $5 bills. T is the number of tens. If we add the number of fives and the number of tens, we should get the number of bills, which is 124. This is not the value of the money. This is not what it's worth. These are the number of bills, and they tell us the total is 124. Total means add. Now that's only one equation. We can't find F and T with just one equation. So they give us another value. They say the total value of the money is $840. Now each $5 bill is worth $5. Let's say on the side here we have 9 fives. 9 fives, okay? How much money would that be? Well, it's the number of bills times $5, which is 45. Okay, now this is just a different example. I like to think of number examples when I get confused, because sometimes the variables can make it kind of confusing. So however many bills I have, I just multiply it by what the money is worth. So if we have $5 bills, now I don't know how many I have, but I know that each one is worth $5. So if I have 10 bills, it's 5 times 10. If I have 18 of these bills, it's 5 times 18. Each $10 bill is worth $10. If I add the value of the fives to the value of the tens, I get the total value of the money, which is 840. Here's the system. Equation 1, equation 2. Excuse me. Now we need to solve. So we need to make a decision. Would we rather eliminate the F's or would we rather eliminate the T's? In this case, I am going to eliminate F because it's a little smaller. That's 5F. I want to make this a negative 5F. So I need to multiply. This is a 1 right now. I have to multiply everything by negative 5 to do this. And so equation 1 becomes negative 5F minus 5T, because I have to distribute, equals negative 620. And then the second equation stays the same. 5F plus 10T equals 840. And now we can eliminate. So now we need to add the equations because we have opposite coefficients. 0F. Negative 5t plus 10t is 5t equals 220. Divide by 5. T is 44. Now what does that represent? T is the number of $10 bills. So if we want to find the number of fives, let's go back to the first equation because that was the easier one. F plus T equals 124. Well, that's easy enough to solve. We just subtract 44. F is 80. How many of each kind of bill, how many of each kind does he have? 85s, 44 tens. Now one last thing here, and if you plug it in, 80 plus 44 is 124, check. 5 times 80 plus 10 times 44 gives us the value of the money, check. I'm going to go back to the original equation, the original system, I'm sorry. If you say, well, wait a minute, could I have done substitution? Yes. Let's say we had taken the top equation here and solved it for F. Okay, so what if I had gone minus T on both sides? I would have gotten F equals negative T plus 124, which I could then substitute into equation 2. 5F plus 10T is 840. I would have substituted the negative T plus 124, and then I would have distributed, combined like terms, and then subtracted the 620, and divided by 5, I would have gotten the same answer. So if you like substitution better, you can use substitution. I just prefer elimination when the variables are on the same side. That is the end of part 1.